My name is Bajaj. I wear two hats. I have been working on SysML v2 API for 10 years now. A lot of gray hair has developed in that time frame, but it's been an exciting journey, and I want to share with you why we have the SysML v2 API and what kind of capabilities for the digital thread it's going to enable. And I'll show you some demonstrations, some examples with multiple vendor tools. Many of you are sitting in this room, so you can see how this would interplay with all the tools that all the vendors are producing today. I am also the Chief Systems Officer at Intercax, so some of the tools I'm going to show you are going to be what we develop, but also a lot of the partner tools that belong to vendors out here. Okay, so we'll talk about SysML v2, and we'll talk about digital threads and why we feel that's a game changer for integrated digital engineering. But we'll dive into it a little bit. We'll talk about the SysML v2 API and language and how it facilitates an open, scalable digital thread. What can you do with the digital thread? No, it's not a glorified database of hyperlinks, as some of you may have been told. There's a lot of power. It's a central nervous system of your enterprise, of your system. It's the thing that will power the digital twin. So I want to show you capabilities like navigating it, querying it, visualizing your digital thread, doing CI/CD pipelines. We heard Daniel this morning talking about CI/CD for digital engineering, so we'll talk about that. Metrics, reporting, authorization, authentication, security. They're all aspects of different dimensions of the digital thread. But I want to also talk about data science and artificial intelligence and large language models and show you some demos of what's possible with standard APIs. Okay, so organizations that are developing large complex systems are developing the system in a variety of tools in a variety of domains. You've got requirements management, you've got system architecture in SysML v2. That's the piece we are here for, that piece in orange. But you also got detailed design and manufacturing that's happening in CAD tools, mechanical CAD, ECAD, PLM systems. Now we've got a new elephant in the room, which is called software. Every system is so software intensive. And the tools that develop software or manage software are very different from traditional hardware tools. So you're probably familiar with GitHubs and GitLabs and the Atlassian suite like Jira and Confluence. So that's another dimension of the problem. Then you have simulation models all the way from lumped parameters, simple low fidelity models to high fidelity 3D FEA CFD models, project management, test management, and it goes on. The biggest challenge you have is that how do you define a system when the data is actually distributed across different disciplines and domains? And then each of the disciplines are doing their own version control and configuration management. So how do you configuration manage the entire digital thread that connects all of this together? How do you do cross-domain impact analysis? Your data is not in a single tool that you can kind of navigate and query it in one tool. You have to go cross tools, cross boundaries to do navigation. When things change, you have to propagate that information change across disciplines. You have to verify and validate your product description across the silos. And you have to do CI/CD releases, not just for software, not just for hardware, for the entire system at major criticals, PDRs, CDRs, milestone, whatever terminology your organization uses for release processes. And there's a big challenge on cybersecurity and intellectual property. Any organization is developing a system of system. You have partners who have their own IP that must be protected as part of that digital thread. And you want to share data, you want to connect data, but you have to keep an account where cybersecurity plays in. And as I said, this is fundamental to the digital twin. So what is a digital thread? I'll give you my definition, and I'll share with you what DoD Instruction 5097 says, and you'll see how kind of they match up. According to us, a digital thread is a large graph. How many of you use social networks today? Facebook or LinkedIn or whatever. Think about social network for models, but not models, but like individual artifacts and elements and data that's in those models. That's what a digital thread is. The only challenge is that this is a social network that doesn't belong to one single tool or vendor ecosystem. It's a social network that belongs to your organization, your data, and it's distributed across multiple tools and environments that you're using. So it becomes a very challenging problem when you have to coordinate this. You can see different ways of arranging this social network. There's MOF models, a digital thread. This picture shows one example topology. This is not the way you want to always arrange it. If you're a hardware-centric organization, the PLM system might be the center of your world, and everything radiates from that. If you're a software-intensive organization, the software system might be a center of the world. So this is one topology of how you get it connected. But what you can see is that each different bubble over there, colored bubble over there, is like a discipline which uses certain classes of tools. You see system architecture in turquoise blue. You see on the left-hand side, you see requirements management. You see hardware and manufacturing on the top. You see software, test management, CI/CD deployment on the bottom. And each tool is very good at managing the thread within it. But it's really the bridges across the islands that is a problem, right? And as I said, this is not a glorified hyperlink because you have to have things flow on those bridges. It's no point in having a digital thread where you kind of hyperlink things. The data has to flow seamlessly across these different disciplines, and you got to maintain the thread. Now, you want to ask, like, who gets access to the thread? It has to be open because the hardware engineer needs to know what are the upstream requirements that may impact them. The software engineer needs to know what are the upstream requirements or architecture elements that impact them and downstream. So every discipline needs to have access to this digital thread. And hence, it's so crucial that this thread be not be inside a single set of tools. It's kind of open. It's your enterprise's IP. All right. But let's look at the, don't take my word for it. Let's look at DoD instruction 5097. I think Daniel was here this morning, so you'll like this slide. But the DoD instruction 5097 clearly identifies digital thread as a foundation for doing digital engineering. It's what will drive the digital twin. You can't have a digital twin without a digital thread. And it states that it's an interplay of technical data, software information, knowledge in the digital ecosystem, which is kind of a high-level statement for that graph social network view I was talking about. So let's look at SysML v2 in particular and see what's in the language that makes it easy for us to plug and play architecture models into a digital thread. Well, the first thing I think is most impactful is a very harmonized language. As you can see on the left-hand side, this is SysML v2 terminology, and the right-hand side is SysML v1. We are dealing with some key patterns of definition and usage, and that makes it very easy to navigate and query architecture models and plug and play them in a large digital thread, which means if you're navigating into requirements or structure or behavior, the same set of concepts is going to drive it, right? That's one of the key parts of it. But the other big piece of it is the systems modeling API and services. There's another standard which is coming out with the SysML v2 language and the kernel, is the SysML v2 API and services. And this one provides standard sets of API and services to interact with SysML v2 models. You could have providers and consumers of SysML v2 information that can interplay seamlessly amongst each other through this standard API. And what does an API do? In very simple terms, it standardizes the kinds of questions a consumer can ask to a provider and the type of response that a provider can give back to the consumer. That's all it is. Standard format to ask questions, standard format to get the answers, and standardizing the type of questions you can ask. Very powerful. So what happens with this today? So typically you have been used to kind of building SysML models through the diagrammatic way. But now this opens up doors. We can actually build models using textual notation as the language enables. I think Ed was showing that, but also through the API directly, which means I can do automation pipelines. I don't need to sit there and create diagrams. I can generate the SysML v2 model through an API, and that model would work with any vendor tool. I can have AI generate that model without hallucinating, as Ed was saying, right? We'll show some examples of that as well. So what has happened today? Right now, if you have an application you want to develop internally, you develop that application specific to a SysML UML modeling tool, which has its own API, which is not standardized, and it may be in a specific programming language, which makes it very difficult because when you change from one tool to the other, you really have to rewrite your application, 3 different versions of your applications to work with 3 different tools. But what happens next with a standard API? You write your app once, and through that standard API, it can interplay with any vendor tool, theoretically. We have to still see how that plays out. But that is the goal of the SysML v2 API, to provide that common interface across which we can exchange system engineering information, architecture information, and have your app. And now what's the impact of that? Well, this thing on the right-hand side, your application script, is not just an app you build in your company or a dashboard you build for a program. This could be the entire digital thread. So imagine like you could have system engineering information coming from different vendor tools, just plug and play into a digital thread through that common API, okay? So, and within the SysML v2 submission teams, we kind of tried that. We had different vendors who were, interacting amongst with their own tooling with the API, and kind of have this microcosm of what's going to happen in the real world, where you have consumers and providers of that information and playing with it seamlessly. You had like MapleSoft, you had some work that Hans Peter did. You had Tom Sawyer there. You had Art Platform Zendaya doing the digital threading, and all kind of interacting with that common API, right? Very powerful. So let's talk about how do you build this digital thread, right, with the SysML v2 API. So it's pretty simple. You can do this, obviously, manually, move information when you want to move, but you can also set up as a CI/CD pipeline. I'll show you some examples of it. So the demonstration I'm going to show you is going to take a textual notation for a SysML v2 model for a spacecraft coming out of Sandy Friedenthal's and Chris Hauser's book, Architecting Spacecraft with SysML, and then it publishes through the textual notation into the repository through the standard API. And then we kind of take that model from that repository through the standard API and are able to transform that model or connect that model to a variety of tools. You can see some of them, multiple PLM platforms like Siemens Teamcenter, PTC Windchill, you got Atlassian Suite like Jira or Confluence, you got GitHub, you got TestRail, you got Jama Connect, and many other tools, right? We could do that, and the S in the middle is a Synta Digital Thread platform that makes that possible. So that's an example. But what do you get at the end of it? You get a digital thread for that spacecraft, where you can see in the bottom those turquoise blue subgraph, that's the SysML v2 piece right here, as you can see. And that's then connected to elements that are coming from different repositories. So for example, the hardware element in the spacecraft architecture model is refined by the parts in the PLM system. The software subsystems are refined by the software modules that might be managed on GitHub. Requirements might be tracked by tasks in Jira, for example. Then you could have test cases linked to this requirement in a test management tool. So you could really build this digital thread live, right, as part of it. So we showed some examples of it. So when we were trying to build this with SysML v2 API, we took the SysML v2 API to get requirements, or for example, in a SysML v2 model for that spacecraft, and just drag and drop it to Jama Connect and kind of generate a requirement structure in Jama. Again, the idea of this was to kind of try out the API for different means and seeing how can we generate models. Is the API rich enough to give us data that we can do model transformations, CI/CD pipelines, compare, and synchronization across a bunch of tools? That was possible, right? We could then take the spacecraft hardware architecture and push it to a PLM system like PTC Windchill, for example. And you can see a BOM structure generated there. We could also take those requirements and say, well, those requirements are going to be tracked in Jira with their descriptions and what the goal of each requirement is, so we can have a proper workflow management there. So we could take that requirement set for the spacecraft and again generate that in Jira as a task structure. So the composition that you have, the common pattern of the definition and use, the common pattern of the membership navigation makes it so easy to do these transforms. You don't have to write apps that do it in different ways. So the harmonization of the language, the availability of a common API makes this very easy and straightforward. We could also have an example where we could take part of that spacecraft and send it to another PLM system. So you could have a multi-PLM environment in your enterprise where different PLM systems are used for different purposes, right? So through ways of transformation, through ways of CI/CD pipelines and automation, we could extract information from a V2 model, push it out to other disciplines, and also put it back into the SysML v2 model as part of the process. So when you do that, that transformation also builds the linkage. The digital thread gets automatically woven when information moves across the disciplines. So let's talk a little bit about what do you do with that thread? How do you visualize it? How do you navigate it? So I'll play this short video. I'm going to talk to you about maybe as it plays through it. See if this works. So you have here, if I go back a little bit, you have here a dashboard that shows how many digital thread projects are being managed. So you see there are 32 repositories from where the information is coming. You see like all of your favorite tools there. You see Teamcenter, you see Windchill, you see Jama Connect, you see Teamwork Cloud over there. You see TestRail, you see Zuken Tools, you see Artifactory, GitHub, GitLab, pretty much everywhere the information could be coming from. But then we're going to go into one specific digital thread for the spacecraft that I was showing you. For that spacecraft, the example I was showing you, which has a SysML v2 model, there are only 7 repositories participating in there, right? You got SysML v2 repository, Teamcenter, TestRail, Jira, and so on. And across those 7 repositories, there's 7 projects and 185 artifacts that are actually connected. The graphs at the bottom show kind of the timeline of how that digital thread is growing, right? Now, what we can do is we can go into a SysML v2 repository. So what you're seeing over here is the SysML v2 pilot implementation we have in the OMG SysML submission team. It's using the API to navigate that model from here. But this would work exactly the same way if you had SysML v2 API that's offered by Teamwork Cloud 2024, or it's offered by Syson or SAM or other tools, right? It's the same process would just work seamlessly with it through that common API. So we're going to go to that spacecraft model. And I can start to navigate this in like a tree view. So I can look at the spacecraft package. I can look at the outgoing relationships in a tree view from that spacecraft package. SysML v2 meta model is a very graph-like structure, so you can navigate things like a graph. Obviously, you can do color coding and change display names and things of that sort, but you can start to visualize that social network. In this case, you're looking at only the SysML v2 model graph right now. But I expand that spacecraft, and I can see that the spacecraft assembly is connected to a part in a PLM system, the green nodes over there. And if I expand that now, I'm able to fetch the data from Teamcenter, for example, and see the model that's within the SysML v2 repository, along with the BOM structure that's in the PLM system, and see how they're connected at the artifact, at the item level, right? And so you're seeing now a realization of that cartoon digital thread I was showing you a few minutes ago. So you can see that navigation connecting it, right? And so now this is a live digital thread. As I mentioned, this is a live network. So I can right-click on that element, and I can go to, maybe if it's in Teamwork Cloud or it's in PLM, in this case, it's going to Siemens Active Workspace, to look at that PLM BOM structure for the spacecraft, which was automatically generated from the V2 parts usage tree. So you can see that BOM structure in Teamcenter. Now, if I expand that, I can go to any part, and again, you don't have to open it at the assembly level. You can go to every part and look at the navigation of the specific parts that are connected. Now, there's an avionics subsystem in the SysML v2 model, and that avionics system has an onboard computer. And that onboard computer has flight software and mission software that's coming from SysML v2 model. But we have had that connected to the corresponding software modules on GitHub. So the purple nodes are the software code on GitHub that's part of that digital thread. So you can see hardware and software both connected to the SysML v2 model through that common digital thread. So I can right-click and go to GitHub and see my software module there in GitHub. I'll move this along a little bit, probably you get the idea, but we can do the same thing with requirements. I could have requirements in the v2 model that's linked to a detailed requirements management tool like Jama Connect or DOS NextGen or anything else, and you could be able to navigate that. We could also have requirements that are linked to tasks or stories in Jira, and so you can expand that here. Just like we were expanding it, you can see that space one is a Jira issue, which is linked to that's the spacecraft requirements coming from SysML v2. And the same structure you see in Jira, you can see that as part of that common digital thread, right? You can navigate and see relationships within and across Jira. You can also go into test cases. So we have requirements in the spacecraft model in SysML v2, which are linked to test suite in TestRail for the launch vehicle interface. And so you've got mechanical interface, electrical interface, and so you can, once it's part of the digital thread, you can navigate to it and see when was the test last run, did it pass, did it fail, and so on and so forth. I think you get the story of that, right, how that plays. But you can also take the digital thread with the SysML v2 model and extract analytics out of it. For example, I want to know, for that spacecraft digital thread, how many issues are in Jira? Who's working on them, right? How many are open? How many are closed, right? If I make a change in a connected model to that SysML v2 model, does it automatically update? Can I get reports generated out of my standard SysML v2 model? And that's part of the process that you could go through, right? So again, I'll not belabor on this. You kind of get the idea. So let's just move to the next part of it. And this. Okay, but we also want to measure what are the three important things that any project or program manager cares about: cost, risk, schedule, right? So if you care about those, very often you will see in your companies that you have people who are creating a bunch of spreadsheets that are taking this data from different disciplines and trying to roll up some numbers in a spreadsheet to give some realistic estimates of how much cost you burn down, how much risk you have, what kind of programmatic risk or hardware, software risk you have, what does your schedule look like, are you going to meet the deadline or not. But we argue that the digital thread is because it's a social network of models connected, don't build those spreadsheets. You can actually use that digital thread to kind of get data and you can roll it up. So those cost, risk, and schedule metrics you have at the top could decompose into system and process level metrics. Like schedule is a function of how much activity is progressing, how much of work is complete. Cost is a function of the activity that's going on in your program. Are your models consistent? What is the complexity of the data and the systems that you're designing? It's a function of those. And then you break those down into other low-level metrics that you can get from the digital thread. So for example, I could be looking at a SysML v2 model and looking at a spacecraft and see how many requirements do I have in the spacecraft. And then I would say, well, where is the testing for these requirements happening? Where's the verification happening? And the digital thread would lead me to the test cases. I could measure how many requirements have a test case versus how many requirements don't have a test case. Well, if they don't have a test case, you've got a completion problem. So you can compute numbers like percentages of test cases versus percentage of requirements that don't have a test case. And out of those that have a test case, how many tests are actually passing versus failing? So you can get this information live out of a digital thread, and you can roll it up into program level metrics. If you're interested, there's a link to a blog series we wrote on how we can use the digital thread to do programmatic risk assessment and cost and schedule. Let's talk about configuration management. This is an area where SysML v2 really shines. Within the SysML v2 API, there's a concept of change. So when you change a project or change a model that is written by the project, you actually create commits in a SysML v2 repository. These commits, think of them as snapshots. So at a given commit, at a given snapshot, you can see the delta, the change that happened at that commit compared to the previous commit or commits, because there could be multiple. You could have a branch and merge kind of situation. But you can also see the cumulative list of elements in that SysML v2 model at that commit. And you can do branches. So each bubble over there is a commit, and you can see the blue branch of commits, and then you can see that the orange branch at the top was branched out of that blue branch over here. And then you can see the green branch over here came out of commit C7. So you can see like a commit graph, and a SysML v2 repository can actually represent this commit graph. It's not trivial. The vendors who are implementing this and the pilot implementation, kudos to them for implementing this. This is such a powerful capability for configuration management. It's almost like a Git-style versioning system that's built into the SysML v2 API, right? And what you can do with it then is that, as you can look, you have got not only the concept of a branch, but you can also have concepts of a tag. So you can actually create milestones of your SysML v2 model over time. And so you can kind of compare your model across the different branches or across the different tags that you may apply to it, right? So the v2 API and the v2 SysML v2 PIM, the platform independent model for the API, allows for this type of representation. You can also have a very nested project usage structure. You have libraries that are released, and they're released on a different schedule. And then these libraries could be reused by other projects that are following their own versioning lifecycle. So you have not only a commit graph for a particular project, but you have a project of projects, right? So kind of have a usage tree out of that. Again, very powerful concept. But the question is, this is just looking at a SysML v2 model. It's looking at version management of a SysML v2 model. But then if you look at a PLM system, it is doing its own configuration management and baselining for the hardware. If you go to the software repository, it's doing its own configuration management. So when you combine this in the context of a digital thread, you got to think about baselining the entire thread. And you want to do a diffing across the baselines of the thread to see how is my thread growing over time? What relationships in this thread are being added? And so that is another key capability that a digital thread capability that you could have. So you could have baselines. In this case, I have an example for the spacecraft. I've got three baselines for the digital thread, and we can do a diff across the baseline. The first baseline, the requirements were connected from within the SysML v2 model requirements repository. In the second baseline, we had connected the hardware elements in a SysML v2 model for the spacecraft to the PLM counterparts. And so you can now do a diff and see how many relations, how many edges in that graph grew over time. Very powerful, because you can then do diffing across these baselines, can tell you how that digital thread is growing over time. Authentication and authorization. This is very important, right? A key piece of it. Now, I want to talk to this from a SysML v2 API perspective, and I'll talk to you from a digital thread perspective. From a SysML v2 API perspective, authentication and authorization was not in the scope of the standard. That doesn't mean it's crucial. That doesn't mean it's important, but it was not something that we wanted to standardize, because there are already authentication protocols out there, right? You've got LDAP protocols. You've got single sign-on with SAML2 protocols. There are tons of them. You've got like API tokens, peer auth. And there's a world out there in security and network security, which is already standardized these authentication protocols. So we do not want to kind of invent something new. So within SysML v2 API, you've got the concept of a project. It was defined specifically for this, When you connect to a repository, you can use any different authentication protocol that the vendor provides. For example, if you're working with Teamwork Cloud's implementation of SysML v2, I'm actually using this right now. So you can use your basic authentication or OAuth. If you're using some other vendor repository, you could use another authentication scheme for that. So it doesn't try to prescribe to the vendor of what authentication schemes to follow. But at the concept of a project, which is defined in the API, you could have an overlay an authorization scheme. What kind of permissions a user might have on that SysML v2 project? Who can create the elements, who can update the elements, who can create the commits, who can create the branches, who can create the tags and baselines on that SysML v2 model. So that's the key part. It is very orthogonal concept. It was intentionally kept left out of the standard. It's nothing to standardize it. It's already out there. But it provides the right hooks that you can overlay authentication authorization schemes on top of a SysML v2 model. But when you talk of a digital thread where the SysML v2 model plugs in, then you got to look at every vendor tool. I mean, enterprises have common authentication layers. You have a common LDAP protocol or a common SAML2 implementation where all of your tools are behind a single sign-on service like Ping Federate or Okta or Microsoft Entra ID, for example. So this allows for this, right, that you could actually have a digital thread where it's through a common protocol you can access and navigate across it. Now, one thing is very important from a point of view of digital thread and security. If you do not have access to some information in some digital engineering repository, like let's say a hardware part or software module, the digital thread is not going to give you a shortcut to get access to it. Just because it's a graph and it's connected doesn't mean that I can't log into my PLM system or I don't have an account to look at a part, but somehow through the digital thread I can navigate to you. So it's very important that as part of a digital threading to be able to preserve the authentication schemes and the protocols that are being offered by the enterprise. Now, you've got the SysML v2 API, but digital threads need their own APIs. A SysML v2 API looks at a SysML v2 model and extracting information out of it and creating, reading, updating, deleting information in a v2 model. But the digital thread itself needs an API. And that's something we've built over the years. There's an API that we offer for the entire digital thread, as well as all the integration tools that you connect to. They have their own, we have a unified API for all of them. So we can actually have a comprehensive API across the digital thread, not only to look at the graph, but like go inside a PLM system or an ALM system and actually navigate the data through a common API. And what does that do? Then you can use that as part of an interactive computing platform like Jupyter Notebooks, right? You could have the SysML v2 model along with its API, along with the APIs that you have for other digital threading aspects. You can combine them and to create your own custom dashboards using latest data science libraries from Python, right? Matplotlib or Plotly or whatever that you may be using. Combine that in Jupyter, take the data out of digital thread and show it, in like linear charts or histograms or stack plots or pie charts, whatever information you want to share with your stakeholders. And that's the power of open APIs out there. But let's talk about AI, right? There's a lot of buzz around it. So I want to talk to you a little bit about it. Modern world is moving very rapidly. We heard about APIs and hallucinations of AI. Large language models are really good at getting better and better, and I would say commoditized at understanding natural language. And standard APIs are very good at reaching out to your data, your enterprise, your software, your systems. If you combine large language models with APIs, you get an AI agent. So you can use the LLM to understand natural language, but then you can use their APIs to run those queries. And I'll show you how I can now, with a SysML v2 API, chat with a SysML v2 model through a large language model. So let's see that in action. So we'll show a couple of examples here. We'll show an example of chatting with my SysML v2 model, but we'll also have a conversation with our digital thread and different digital engineering repositories as part of this interface, right? So I can log into a dashboard where I can kind of provide my credentials. So I can log in and get access to my digital thread projects that I'm working on, including the SysML v2 repository. Once we log in, we'll go to, on the left-hand side, to a SysML v2 AI agent on the left-hand side. It's like a chat GPT-like interface. You've got certain prompts. I'll pause this a little bit. So you can see there are certain prompts, but you can type in your own query at the bottom. And when you hit the prompt, one of the standard prompts, or you write your own query in natural language, it can actually interact with a SysML v2 repository through the standard API and give you responses. So let's play with it. The first one says, can you Okay, I'm sorry. I think the audio is on. So I was wondering where the audio is coming from. Hold on. Okay, better. So the first one says, give me an element of spacecraft of type part usage. So it goes to the repository and gets me that element of the spacecraft from a SysML v2 repository, that spacecraft. I can then ask it, give me a requirement called spacecraft specification. Again, these are natural language questions it's getting. But then I ask it, get me features for a spacecraft assembly. And it's now going through using the API, the back end with natural language inputs and getting me a full decomposition of the spacecraft assembly, the same spacecraft that we push into the repository through the textual syntax. So imagine what we've done. We have taken textual syntax, we have pushed it to a repository through the standard API, and we can use that API to extract, but we can also use artificial intelligence to take natural language inputs and ask the same question, but now instead of me kind of figuring out the query language for the SysML v2 API, just ask it questions, right? And then these could be free-form questions, right? So for example, I can ask it, okay, you got me that, how about the avionics subsystem? It understands when you say, how about the avionics subsystem, it understands that you're asking about the avionics subsystem, so it's going to fetch you the decomposition of the avionics subsystem up part of it. So you can actually have a conversation. It can record the history of the conversation. You can go and ask, can you tell me the last 5 questions I asked? You got it, right? So you can do that. Now you can extend that to other parts of the digital thread. I can do the same thing with a PLM environment. I can have a chat agent here for Teamcenter, which if I can ask the item ID, it can give me an item out of Teamcenter. I can ask it, just like a SysML v2 module, I can ask it, give me the BOM structure for an item. So it's going to iterate, go to Teamcenter, fetch the data, and generate kind of a nested structure inside the chat interface. And I can get the full BOM for any assembly in Teamcenter through natural language, right? Again, the power of APIs and AI agents, you can do these kinds of things today, right? Let's try something else. Again, these are all hyperlinks. If you click on them, they'll go. If you look at the Windchill API agent, then you can actually look at the Windchill piece of it because we pushed the spacecraft model from SysML v2 to Windchill as well. Again, the same thing. You can ask the question for a part number or a BOM, and then it will generate it for you, fetch it live. And then it's hyperlinked, so you can click on it and you can go to the native repository, the authoritative source of truth for that hardware, and you can look at the data in there, correct? It's going to go to Windchill there, and you can see that in Windchill, and you can see the structure of that aircraft platform that's in Windchill now, the BOM view it's opening up, which is pretty much what it printed you in that nested sheet. But you're interacting with it through natural language. Now let's make this a little bit more complex. Now, navigating and asking questions to individual repositories is sort of the easy part. The questions can then become a little bit more complex. If you start asking questions like, can you tell me the latest status of all the Jira issues or all the test cases I may have in my digital thread? Then it's got to do a little bit of thinking about it, because the first thing it has to do, it has to go to your digital thread and to figure out, do you even have Jira issues participating in a digital thread? Do you even have test cases? What are they linked to? So it's got to first find out what data is connected. And then it has to go to the native repository like Jira or TestRail or a PLM system to find out what the latest status on that part or that requirement is. Is it in progress? Is it done? So the questions can become a little bit more complex. And this is what LLMs are good for. They can take complex questions, break them down to simpler things that APIs can handle, right? So here we've combined multi-agents, like a swarm of agents that can actually talk. So here we are asking, can you give me the latest status of all the Jira issues in this spacecraft digital thread? It's got to first figure out what Jira issues are there. Obviously, they're linked to the spacecraft requirements coming from SysML v2, but then it has to go to Jira to figure out what are the test cases and what's the data status, and produces this color-coded report out of it through the chat interface, where you can see the list of Jira issues for the spacecraft with a color-coded table. The coloring is based on the status column. So you have like the dark orange means it's progress, green would means it's done, bisque would mean it's still to be done, right? So you can actually make these complex questions which are broken down, and you can have agents interacting with other agents. So very powerful, right? There's a paradigm shift in how you work with your data. You can really talk to your digital engineering repositories and really talk to your digital thread. Let's look at a couple of more, and I'll kind of wrap it up soon. Let's look at this one. It's a multimodal agent, so it can actually take text and voice both. So if you don't feel like typing on a certain day, you can actually record your voice and do it. So let me see if I can amp up the volume on this one. I'll stop talking and see if I can amp up the volume. So let's just see. So I asked an audio question, recorded my voice, generated a natural language sentence out of my voice, sends that request in the digital thread to Jira, gets those issues from Jira, and produces a result out of it. So you literally can use this interface to kind of talk to your repositories. Just an audio that you send, almost like asking Alexa or Google or Siri questions. But in this case, it's not just a large language model looking at the world knowledge on which it was trained on. It is basically using your sentences in your voice or your text to kind of understand what you're asking, break it down to simpler problems, and then using the digital thread APIs to get data from your repositories, right? So that's kind of the jump there. Anyway, some of the demonstrations I showed today are actually part of a recording on YouTube. So if you want to have access to this, those are there. I also want to show you, we did a Christmas special for SysML v2. We actually took a Santa sleigh delivery system model and actually built it up in SysML v2 through the textual notation, and then built a digital thread for Santa sleigh delivery system. The picture you see on the bottom left is actually a 3D CAD model of the reindeer and the sleigh delivery system. There's a package compartment in that sleigh, which has an infinite set of gifts. And I don't know if you notice, we zoom in, the reindeer at the front, Rudolph, actually has a red nose. So that's actually a 3D CAD model in NX for Santa's sleigh delivery system. And you can see that there's a textual notation here for the Santa sleigh delivery system in SysML v2. It's got requirements, it's got the sleigh delivery system architecture, it's got software that powers the dashboard for the sleigh ride, and Santa can get real analytics, and Mrs. Claus can observe from a ground station of how the sleigh is and where it is. But then we kind of build a digital thread for the sleigh delivery system. So that's pretty cool. There's a link to there, so if you have any questions, you can actually go to that link. But with that, I'll end. But I have a few questions for the audience. So when you work with SysML v2 and you look up how that model would get connected, I want you to think about certain questions. Think about, what will you build with SysML v2 first? What's a model that you would like to build in a company with SysML v2? What would a digital thread look like? What kind of disciplines would you like to get connected with that SysML v2 architecture model? Think about it. Write it on paper. It really helps. How would these different disciplines be connected to it, right? What kind of data flows would you enable? Is it just a connection that you want to have basic traceability, or is it like information would flow across that digital thread? What models and data would you implement? Would it be a CAD model? Would it be a hardware, or would it be software that you would like to connect with SysML v2? If you had a digital thread graph, what are the key metrics you would like to measure out of it? Building a digital thread is an operation by itself. So if you have to get ROI on it, you have to know what you can measure, things that you could not measure before. But what are the kind of things that you can measure? Cost, risk, schedule, but break it down further into things that you can measure. What kind of reports, work deliverables that you do today could automatically be generated either through an automation script you write using digital threads, or through an AI engine that I was demonstrating today? It could generate those reports automatically. So what kind of reports would you get out of it? And always remember, digital engineering is about digital threads, not digital silos. The fact that you've got computer models in 10 different repositories doesn't make it a digital thread. And the digital thread depends on digital thread, right? So just keep that in mind. And with that, I'll close and open for any questions.
Hey, Manas, Steve Adler from Northrop Grumman. Did I understand this right? There actually is like configuration management inside the API for SysML v2?
Correct. So SysML v2 API offers you the ability to define commits and tags and branches and services that can do for different and merging of branches. It's baked into the specification. Now, different vendor tools have to implement it, the providers will have to implement it, but the API only provides an interface for doing that configuration management.
So theoretically, then you could run a model and export data through the digital thread, and it could not compare to the test data for the item you're modeling.
That can happen because if you have commits coming, it can go.
Right. And you could extract the module that does that computation, feed it into an AI thing, correct the software, and feed it back. And all of it would be automatic and configuration managed.
Potentially. So one example.
Unbelievable.
Mention what you're saying. If you have a new commit that comes, like a model changes in SysML v2, that will show up as a new commit in the SysML v2 repository. You could have CI/CD pipelines that are listening to new commits and can trigger a workflow when a new commit comes. For example, generating a report or checking against if the test cases are still passing or failing, and generate a report out of it. Very possible. That's why it's there.
Very cool.
Okay, time for one more question.
So this sounds great. However, have you ever been able to implement this on classified or closed networks, especially with vendor development that's closed as well?
Yeah, so typically when you have a closed network, a high site kind of thing, yes, we have customers who have all the tools in that high site environment, and they have a digital thread in that high site environment.
Thank you.
Yeah.
Okay, thank you, Manas.